So we'd like to move on to our next demo, which would be around the collaboration that Intel and Microsoft have done together on virtualization. So specifically, we're going to talk about three features in Intel's processor. So VTX, Microsoft's virtual PC requires hardware assists such as Intel's VTX to run. And we also have some other features that they've taken advantage of. So virtual processor ID is one, and extended page table is another. All of these things together, we've worked on to ensure that the performance on an Intel Windows 7 system running XP mode is very good. Rustin, do you want to come up and talk a little bit about XP mode? So I'm not sure if everybody's familiar with it.
I'm not sure if everyone in the room is familiar with XP mode. This is the ability for Windows 7 using Virtual PC 7. This is the technology we've had, the Virtual PC technology we've had for some time now. But in Windows 7, we've taken this dependency upon hardware-assisted virtualization to get added performance. And with that, we've also been able to take it from its virtualization from its traditional place in the server and start to build some very simple, intuitive experiences on the client that add value. So what XP mode is, as you'll see, is the ability to encapsulate a legacy application, which either for compatibility reasons, an application was written in a business a long time ago, and for one reason or another, it is destined to run on Windows XP, or for compliance purposes, it has to run on Windows XP. Windows XP mode allows that application to seamlessly run on Windows XP within Windows 7, and provides really a safety net for small, medium, large enterprises moving to Windows 7 to know that they'll be able to run those XP generation applications on Windows XP if they choose to or need to. So we'll see a demo of how it's integrated into the user experience, but certainly the hardware acceleration, as Mark will show, enables us to move more scenarios on the client to a high-performance virtualization solution.
Okay. Prashant, you want to launch the demo?
So what we have here is a Core i7 machine running a 64-bit version of Windows. I also have a neat program called Starry Night. It came bundled with the Telescope a few years ago. And when I try to install it on Windows 7, invoke the setup program, it says, do you want to allow the program to run? We say yes. We proceed with the install. And the program runs into an issue because it was incompatible with the 64-bit version of Windows, probably because it was written a few years ago. What we've done is installed the same program in XP mode so that it appears seamlessly on the start menu to the end user. They can just go to the menu and click on it, and it started the virtual machine. You notice a little bar over there, and my program's up. So I hit OK over here. Start the demo, and you can see that this is a fairly resource-intensive application. It's visually compelling, does a fair amount of animation, and it's running under a virtual machine with a great user experience. It's a seamless virtual machine, and the user does not perceive it as a separate environment, and it can run a fairly resource-intensive task. Now, most business applications, most IT applications aren't as resource-intensive as this, but you can be assured that the end user would see a great experience, right, and be able to seamlessly run their apps. Now, Microsoft has done quite a bit of improvements in terms of making a version of XP that fires up very quickly, and once the machine is charged up, you can literally fire it up like that, and there's not even that momentary delay while it brings up the virtual machine. So hopefully this showcases the benefits of the virtual machines and the enhancements we've been able to bring to fruit with additional performance features.
Okay. So next we want to talk about our performance and responsiveness, the work that Intel and Microsoft have done together in these areas, and we'll talk about a few specific scenarios. Rustin will come up in a few minutes, talk about some. Part of what I want to talk about is around hyper-threading. So Intel introduced hyper-threading back at Pentium 4, to recall, and in the Halem, we've done some enhancements to hyper-threading to improve upon it, and at the same time, we work closely with Microsoft to make sure that the operating system recognizes hyper-threading and intelligently schedules the threads. So on the systems over here, you'll see that, quad-core system with hyper-threading, you have the potential for 8 threads running. There's a certain set of software that can take advantage of that. There's some software that cannot. Microsoft has done a lot of work to make sure that Windows 7 intelligently recognizes which systems are hyper-threaded, which are not, and schedules those threads appropriately, both for performance and for power management. So with that, Daniel, you want to come up and start the demonstration?
Daniel Bakey at Performance Engineering with Intel, and today we have a pretty simple demonstration for you. It's a commonly known benchmark called Cinebench. It's well threaded. We're going to be running it on our next out to market processor, Linfield 45 nanometers, one with HT off, one with HT on. Now, the thing that you'll see once I start this benchmark, I'm going to start it simultaneously, and the application is going to take all the available threads to do the operation. The one with HT on is going to have 4 cores, 2 threads each available. The one with HT off only has 4 threads, 1 on each core.
Okay, so that'll take a minute to
Takes a minute
run.
to finish.
So while that's going, let's talk a little bit more about what's been done in Windows 7 to take advantage of this. So there's 3 specific areas that Microsoft worked on for Windows 7, and not just hyper-threading, but for multi-core and multi-threading. So placing the software threads at scheduling time in the right place. So if an application can utilize, let's say you have a dual-core system that's hyper-threaded, if you have an application that needs only 2 threads to run, you want to put those threads on the physical cores for maximum performance. And Windows 7 recognizes the hyper-threads versus the physical threads and makes that decision. And at the same time, if you have a scenario where an active thread is running on a core and you have another available, it'll migrate that core at the right time to improve the performance of the system. And finally, there's another feature in Windows 7 called core parking. So if you have a scenario where there's a core or an application that doesn't need all the cores, they're put into the deep power down state, C6, we've talked about a couple times. And there's a similar, the feature works in a similar way with hyper-threading. It'll park those hyper-threads instead of running them consuming system power. So what's the end result on the benchmark?
This is finished, and on this benchmark you see about 10% improvement with hyper-threading terminals.
And I think on the next slide we show not only that result, so 9 to 10% on Cinebench in this scenario, and also on floating point operations with the Sandra benchmark, we've seen greater than 50, close to 60% improvement on floating point operations with hyper-threading. So as with a lot of workloads and applications, your mileage will vary, but that was part of the analysis that Intel and Microsoft did together in making these decisions with respect to threading and hyper-threading, looking at a wide range of applications that are available in the ecosystem, having Windows 7 make the appropriate decisions on thread scheduling and parking threads for power management, and because of that we see a pretty significant improvement on Windows 7 systems and hyper-threading. Any questions on the hyper-threading part? Because Rustin's going to come up and talk about some of the more broad enabling efforts that we've done on performance and